Let's try balancing a redox and a base. So we're going to determine the oxidation numbers use to decide what's being reduced and oxidized. So the oxygen is -2, manganese is +7. The bromine already is given as a -1. Oxygen -2, manganese over there is +4. Oxygen there is -2, and the bromine is a +5. So now we can see that manganese is being reduced. It got electrons to go from a +7 to a +4. The oxidation is being, or the bromine is being oxidized because it lost 6 electrons. We're going to split those into the half reaction, one for the oxidation and then one for the reduction. And now we're going to balance all the atoms except hydrogen and oxygen. So we see that the manganese is balanced over there. Got the reactants and products. Manganese has 1 on the reactants, 1 on the products. That is balanced. Oxygen is 4 on the reactants and 2 on the products, but we're not going to worry about that yet. Let's go over to the bromine. The bromine and the oxygens, that's all they are right now. The bromine, there's 1 there and 1 there, so that's all balanced. The oxygen is 1 and 3, but we will balance that in the next step. So we're going to balance the oxygens by adding twice. Now here's the key. We're going to add twice as many hydroxides to the side needing more oxygen. So in this reaction, we need 2 more oxygens. So that means we're going to balance by adding 4 more hydroxides. It's okay that the oxygen will not be balanced after this step. They will become balanced in the next step when we balance the H's because we have to add water. So we add 4 hydroxides there, and it might be confusing. You might say, well, that's not balanced though. But there's a reason we have to add twice as many, because we're on the other side, we're going to add water. So and water will have more oxygen in it. So that means that's why we have to balance with twice more. So don't worry about that. Just do twice more initially. As we can see, we also added 4 hydrogens. And again, we're going to balance those hydrogens in the next step. We just had to initially start off with the hydroxides. The bromine, we're going to add twice as much. Again, so notice there's 3 here, so that means we have to add twice as much hydroxides to balance it. Now we have 6 oxygens there and 3 here. Again, we will balance that in the next step completely. We just had to get a starting point. We now added 6 hydrogens to the reactant side, and the product side has 0. And again, that will also be balanced in the next step when we balance the hydrogens. So we're going to balance the hydrogens by adding water to the side, needing more H's, more hydrogen. Remember, there are 2 hydrogens in water, so add half the number of hydrogens that you need. We need 4 hydrogens, as dictated here. So that means we add half of that, and that means we have to add 2 waters. Now let's see how the numbers work out. We're good with hydrogens, 4 hydrogens on the reactants and 4 on the products. And look at there, we balanced our oxygen. So that is why we had to add twice as many hydroxides to this side, because we added half as many waters. So everything balances out there. Let's go down to this equation. I have to add 3 more waters. We needed 6 hydrogens, so again, we add half as much water as we need, so that's 3 waters. So let's count 6 hydrogens now. And what does that do with our oxygens? We're adding 3 more oxygens, so that means we bring a total up to 6 oxygens. We're balanced with hydrogen, we're balanced with oxygen. Okay, so all the H's, everything is balanced. H's, manganese, bromines, and oxygens. But now we have to deal with the charge. So the total charge in the reactants product, then we're going to add electrons to balance these charges. Okay, so let's look at those charges on each of those half reactions. The charge is -1 for the reactants here and -4 for the products. That means we're going to add 3 electrons to balance out that total charge, and that means we have a -4 total charge here and -4 there, so we're good. So let's look at this next one. The charge is -6 for the reactants and 0 for the products. That means we're going to have to add 6 electrons to the product side. That'll bring a total charge of -6. Okay, and then we go to the next step. electrons should need to be added to the reactants in the reduction half reaction, that's this one, and to the products in the oxidation half reaction. But we don't really have to remember that. All we have to know is where to balance it by just looking at the charges. The next one is multiply the half reaction by a factor to make the electrons lost equal to the electrons gained. So we have 3 here and 6 there. So the common factor will be 6. So we'll have to multiply the top one by 2, bottom one by 1. So again, we're going to have to distribute this 2 to everything in here, all the elements, all the compounds. So then we get this full total reaction, which is a lot. But remember, we can cancel out just like we did in the acidic one. What appears on both sides? Well, we know electrons are the same, so we can cancel that out. That's why we did it. So we cancel those out. Those are gone. The hydroxides also appear on both sides, as well as the water. We're left with 1 water there. All those waters go away. The hydroxides will cancel. We'll have 2 left on the product side. And this is our final reaction because nothing else can cancel out. So we can see that it is balanced. And that was doing it with the base method. So it's really pretty identical to the acid method, but the only exception, we add twice as many waters. So there it is. It's balanced. Okay, so let's try another one in a basic solution. Before we write the half reactions, though, we have to give the charge, the oxidation number charges. So this zinc is 0, the oxygen is -2, so the mercury must be a +2. The oxygen here is a -2. There's 2 of them, so that's going to be a -4, but the overall charge is a 2-, so that's going to be a 2+ here, or I should say a +2. And then the mercury here is going to be 0. So let's see what was oxidized, what was reduced. Zinc went from a 0 to +2. So that means it lost electrons. It was oxidized. Mercury went from a +2 down to a 0. It got 2 negatives. So that was a gain of electrons. It was reduced. So these are the half reactions for the oxidation or reduction process. So these are the half reductions for the oxidation reduction processes. So now we go on to the next step where we start balancing. So now we're going to balance the half reactions with respect to the atoms involved except for hydrogen and oxygen. So that means we're just balancing the zinc and the mercury. The zinc is all balanced, and the mercury is balanced as well. So everything's balanced. Now let's just go on to balance the oxygen and the hydrogen. So we're going to balance the oxygen atoms by adding twice as much hydroxide molecules, the side that needs more oxygen. Add twice as many. So that means we need to add 4 hydroxide molecules. That side, we needed 2 here. And on this side, we're going to add just 2 hydroxide molecules. Everything will really balance out once we add the hydrogens, which we'll do in the next step. Now we're going to balance the hydrogen atoms by adding water to the side that needs more hydrogen atoms. On the top reaction, we're going to add water. And how many waters do we need? Well, we have to have 4 hydrogens, so we're going to add 2 waters. And then on the bottom reaction, we needed 2 hydrogens, so we'll just add 1 water. Okay, now we can see with both of these reactions, on this side there are 4 oxygens. On this side there's 2 oxygens and 2 oxygens. Oxygens are balanced. This side there's 4 hydrogens, and on this side there will be 4 hydrogens. So that one, oxygens and hydrogens are all balanced. On the bottom reaction, we have 2 hydrogens here and 2 hydrogens there. We have 1 plus 1, there's 2 oxygens there, and then 2 oxygens on the bottom. So both these equations have 2 hydrogens and 2 oxygens balanced out. So let's go on to the next step. We're going to balance the charges now by adding electrons to one side or the other. So let's see, we have 4 negative charge there, and we have 2 negative charge here. So we're going to have to add electrons to balance that out to this side. 2 electrons. Let me rewrite this. And now both sides have a charge of -4. How about the bottom one? Well, this bottom one, we have two negative charges on the product side. So let's add 2 electrons to the reactant side. We now have the charges balanced on both sides. 2 negative here and 2 negative there. As well as the top side, we have 4 negative here and 4 negative there. The charges are balanced. Let's go on to the next step. So now we're going to balance the electron charge in the 2 half reactions by multiplying the 2 half reactions by the least common multiple. But the thing is, we have a 2 electrons here and a 2 electrons here, so we don't have to multiply it by anything. They're already balanced as far as those electron charges. So now we're going to add the 2 half reactions back together. So here we added the 2 half reactions back together again. Got this big long line of things, but we can cancel things out in part 8. On 8, we're going to cancel anything out that appears on both sides of the final equation. At the very least, the electrons should cancel out. And the electrons do cancel out here. So I'm just going to erase that. Now the water, let's look at the water. We have 1 water here and 2 waters here. So we can get rid of this water, and we're left with 1 water over on this side. And what about the hydroxide here? We can get rid of 2 hydroxides here, so get rid of those. And this is the balanced reaction, the final balanced reaction. So they seem like there's a ton of stuff to do and a ton of stuff to remember when you're balancing redox equations, but really the more you do it, the more you'll just get used to these steps. And it's not as though you have to think of step 1, step 2, step 3, steps 4. You just kind of do them the more practice. So practice this stuff. Practice makes perfect. Just get examples and do it over and over until you don't have to think about it anymore.